Hello everyone, this video will look into an example question by using Nernst equation. Okay, so this is a very important equation for electrochemistry, so then let's look into it. Okay, so for this, again, for Nernst equation, you probably realize that's one we probably dealing with a non-standard condition, okay, and then we can use the equation itself. Okay, so let's start with the equation. Okay, so E cell equals to E naught cell minus 0.0592 volts divided by number of moles of electrons involved this redox reaction log Q. Okay, so this is the equation itself. So again, now let's see, we need E naught cell, and which the question is actually giving us. E naught cell for this reaction is positive 110 volts. Okay, so that's given. And then we just need to figure out number of moles electrons involved this redox reaction and the Q itself. Okay, so let's figure those out. So let's look at what's going to be number of moles of electrons. And go, I don't really see it because, again, we have overall reaction, but always when we check oxidation numbers, that's going to help us to figure out that information, right? So let me do this again. Okay, let me copy this equation. Let's assign oxidation numbers. Okay, so this is a very easy equation at 0 to positive 2, positive 2 to 0. Okay, so then you'll have zinc, which is go through oxidation number from 0 to positive 2. So oxidation number increase, that's your oxidation half. And then copper, on the other hand, is going from positive 2 to 0. Okay, for every one copper, that's oxidation number decrease. Okay, so as I said, oxidation number is helping us to track the electrons, right? So from 0 to positive 2, that's involving 2 electrons, every 1 zinc. And then, yes, it is just 1 zinc involved. Okay, let me use the blue color. Okay, and then the same way for the reduction half, that's also for copper. Every 1 copper is from positive 2 to 0, which means it gained 2 electrons for this change to happen. Okay, so then again, you go, okay, that equals to each other, that's fine. That's also what we need, right? We need to make sure they're equal to each other. Okay, so that's what I have. You go, that's nice. I know now it should be 2 moles, right? Okay, so I'll bring this. Okay, so let's bring this down. Oops. Okay, let's bring this equation. So now we figure out number of moles of electrons. Then we can plug it in. Okay, so in our cell, which is given from the question, positive 1.110, and then have 0.0592 divided by 2 moles of electron log of Q. Q is products over reactants, so solid is out of the picture. So product will be zinc concentration over the copper concentration. And their coefficients are just 1, so simply just division of the concentrations. Okay, so but just as a heads up, right? So you do need to make sure you double check the coefficients. Okay, so for this question, it's just there's no stoichiometry, right? There's no stoichiometry there's stoichiometry coefficients 1, so that's fine. Okay, now let's plug in the value. That'll be 3 divided by 1 times 10 to the power negative 5. Okay, once you do this calculation, you should get positive 1.110. And then this bunch, you do the calculation with the calculator. This is what you should have. And then the final answer will be 0.94 volts. Okay, and then so the answer for this question is C. Again, this is the E cell for this cell itself. Again, is under non-standard condition. Okay, so that's for this question. Nernst equation, very important. However, it's not hard to understand. And then thank you for listening. Hopefully this is helpful.